Hey everybody, I want to give you a quick explanation behind those trig ratios that are on that table, all those crazy decimals that we were seeing. Okay, they are all based on similar triangles. So I'm just going to go over a couple 30, 60, 90s that we've already done. All these numbers work out for these triangles. Okay, so if you were going to take this triangle here, this first one, and say it's similar to this second one, we could name the triangles and we could write proportions, and all of our proportions would be correct. We could do the same with the middle triangle to the smallest one, or from the big one to the small one. Okay, so for example, on a proportion, if I took this height, we'll call this the height, and divide it by this hypotenuse, I'm going to get a decimal answer. I should get the same decimal answer as I got if I divide this height by this hypotenuse. And I would get the same decimal answer if I divide this height by this hypotenuse. Okay, so if I consistently divide the same parts of the triangles, I should get the same answers. If I divide this height by this base, I should get the same answer as this height by this base. And that's the decimal that appears on those trig tables. Okay, I wouldn't expect to get the same answer if I divide that height by the hypotenuse, because they're not the same sides of the triangles. Okay, you have to use corresponding sides of the triangles, and it works for anything. I could take the base and divide it by the hypotenuse, as long as I do the base divided by the hypotenuse. That's going to get me a decimal that's going to appear on that table. Okay, the 30, 60, 90s we don't really use the trig ratios for because they are nice, easy problems to solve, as you've learned in the past couple days. Okay, so for example, let's say I have this triangle, which is a 41, okay, a 90, and then there's a missing angle up here. We can find that angle if we want. We don't need to use that angle. However, the theory behind trig ratios says if I take this height and divide it by this hypotenuse, that should be equal to, so if I say this A divided by B should be equal to this height divided by this hypotenuse. So whatever decimal I get for this, I should get the same decimal for that one over there. If I want to take this height and divide it by this base, what should that be equal to? Well, that should be equal to this height divided by this base. So let's say I had a triangle over here with a 41 degrees, and I know this number is 10. How would I find this number? Well, this has to equal the same thing these equal. Okay, so hopefully you'll see that on some of the example problems we're going to do on the next lesson. So I hope you found this video a little bit informative, and it kind of connects some ideas with similar triangles for you, and I'll see you on the next video.